Hello students, welcome to E-Lessons. I'm Hakima, your math teacher. Here we're going to begin the next chapter named integrals. Yes, so till now we have been studied about the differentiation. Yes, in the part of calculus we know what is differentiation, we know what is applications of those differentiation, right? So now we are moving to the next topic, which is integrals. Now what is the basic meaning here? Now here the integrals of a given function has a certain definite values. Yes, which means if I would have taken a function y, okay, and I have the function y is equal to, let's say, x cube plus 2x to the power 2 plus 4, and when I derive it, yes, meaning when I take its differentiation, I have the certain rules, yes, how to follow and how to take the differentiation. Now when I have it like this, what am I supposed to do? Definitely apply x to the power n rule, right? What is it? Differentiation d by dx of x power n is n into x to the power n minus 1, right? Now this is the definite way of solving, a definite way of getting its derivative, right? Now the same way we have those definite ways to get the integrals of the given function. One more important point to be noticed here is the integration and differentiation are opposites to each other. Meaning to say is, when I have a given function and I derive this, so I get a dy by dx, right? Now if I would take its integral, I will get back my question. Yes, if I differentiate, I get the solution, and if I integrate, I get back my question. So basically integration and differentiation are opposites to each other. Let us see few concepts here. Let us now study few important results in integration. Yes, so the first one here is integration of x power n dx. Going back to differentiation, we learned the differentiation of x power n, as I've already told you. Yes, the differentiation d by dx of x power n is n into x to the power n minus 1, right? In integration, our function is a little different. What is it? It is x to the power n plus 1 divided by n plus 1 plus c. Now this c here is any constant. Yes, why do I need to put the constant over there? If I have, for example, let me take the given function as y is equal to 2x square plus 5. Okay, and when I take its differentiation, what do I get? Dy by dx is equal to 4x plus 0, right? So here basically the function became 0. Here the function 5 turned to be 0. So when I integrate this, if I would have the function here, integration of 4x dx, then it would have been what? The 4 is a constant, so it will remain as it is with the function. Yes, so I can write it as 4 integration of x dx. Okay, now it is of the form x to the power n. Why? Because it has the power 1. So if I apply this formula here, what do I get? I get it as 4 into x to the power n plus 1, which means it is 2, divided by 1 plus 1, which is 2. Yes, now this and this will cancel. I will just get 2x square. But my function was what? 2x square plus 5. This is why it is necessary for us to write the plus c, because we don't know, there must have been any constant which turned to be 0, right? So here we write a plus c for all the integrations. Yes, after we integrate, in our solution we write it as a plus c. So here basically what is the first result we have? Integration of x power n dx is equal to x to the power n plus 1 divided by n plus 1 plus c. The next one here is integration of 1 by x dx. Yes. Now this is equal to log x. Going back to differentiation, when I had the differentiation of log x, what is its result? Differentiation of log x is 1 by x. Didn't I tell you that integration and differentiation are opposites to each other? See here, we have differentiation of log x as 1 by x and integration of 1 by x as log x plus c. So this is pretty easy for you to remember because they are just the opposites of each other, right? Let us go to the next result. We have integration of e power x dx. Going back to differentiation, we have differentiation of e power x as e power x itself. So definitely the integration of e power x will also remain as e power x itself. Only the difference is we have a plus c. Yes? Going to the next one, integration of a power x dx. Let us check in differentiation. When I had a power x, what do? Yes, we have a power x differentiation d by dx of a power x is a power x log a. Correct? We have it as a power x log a, and here in integration of a power x dx is a power x divided by log a plus c.